Alright, so for question 2.3, basically they ask us to construct an AVL tree in order to delete a vertex which causes 3 groups of rotations. So they give an example of an AVL tree in which if you delete vertex 7, it actually causes 2 rotations, right? So if you think about it, how would we cause rotations? Rotations is basically caused when the tree is unbalanced, right? So the tree that we're going to start off with is going to be as unbalanced as possible. Of course, the tree that we start off with must be balanced, right? Because, I mean, it is an AVL tree, so we have to maintain the AVL tree structure. But what we want to do is to construct an AVL tree that's as unbalanced as possible. So, recall in class that we actually did this recursive formulation of a tree that's as unbalanced as possible. So for a tree of height 0, it's just one node. Right, for a tree of height 1, it's just like this. And then after these 2 base cases, we can actually recursively construct trees that are as unbalanced as possible. So let's say for 2, we just use 0 and 1. So this guy is 0, this guy is 1. And I can just connect it to the root node, and this is the most unbalanced tree of height 2. And for 3, I just take 1 and 2. So this way and this way. And just connect the node, the root. And so on. So for 4, we're going to get on the left hand side the one with 2, on the right hand side the one with 3, and so on, like this, right? And what we realize here is that this is actually the example that they give in figure 2. So the node that they delete is this guy, and it's going to cause 2 rotations. Right, so the question is, how do we get 3 rotations? So obviously what we have to do is to basically construct trees of larger height, right? And then after that delete a corresponding node. So what height should we construct? So during a height of 0, any kind of deletion is going to cause 0 rotations, right? If I delete this, it's not going to cause any rotation. For height of 1, once again, if I delete this, no rotation. If I delete this, also no rotation, so 0. Right, for height of 2, I can actually get 1 rotation, right? Just by deleting this, I'll get 1 rotation. For height of 3 as well, there's only 1 rotation that's possible. And then for 4, they gave the example whereby it's 2. Right, so basically if we follow this order, 5 is also going to give us a maximum number of 2 rotations. And 6 is the one that we want to go for, right? So let's first construct the tree of height 5. So tree of height 5, let's draw here. It's going to be a tree of height 4, which is this guy. Okay, let's draw the tree of height 3 on the left. Right, this is a tree of height 3, and then a tree of height 4 here. And then we're just going to connect these two. Right, this is a height of 5. And finally, the 1, 6 that I really want is the connect 5 and 4. So that is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Right. So let's see here. Hang on. No, okay, so this is okay. In order to construct a tree of height 6, in order to construct a tree of height 6, I need to combine first this guy, right? So 4 is this guy, so I'm gonna draw this guy first. Right, so this is 4. I'm gonna combine it with the one with height 5, right? So this guy. So this guy is this way. Right, and finally this. Right, and this is going to be the most unbalanced tree of height 6. Right, and the question now is which vertex should we delete? Right, so if we go back to the example whereby you actually get 2 deletions by deleting vertex 4, if we think about it logically, we should delete the vertex that is on the lighter side of the tree, right? Because that will make the tree even more unbalanced. And the more unbalanced it is, the higher the number of rotations. So you can see here that they actually deleted the node that is at the lightest, right? So basically, this part is heavier than this, and this part is heavier than this, so it is here, right? So similarly here, when we are using the example of 6, right? This part is heavier than this, so we're going to delete on this part. This part is heavier than this, so we're going to delete on this part. And this part is heavier than this, so this is the one that we actually want to delete, right? And once we delete this, we realize that we have one rotation here, it's the second rotation here, and the third rotation here. Okay, so 3 rotations for this. And the final thing that we have to do is basically to just fill this up with values so that it's a valid ABL tree, which you can basically do. And this tree actually has how many nodes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13, 14, 15, 16, 17, 18, 19, 20, 33. So 33 nodes, right? So you can just fill this tree with 33 numbers and you get an answer for 2.3.